Hey guys, so we are here today to talk about graphing polar equations homework. I picked out a couple problems that are similar to the ones that you're going to do to kind of try and get you going in the right direction, help you think about these a little bit more accurately in the correct mindsets. So you'll notice that when you look at your homework, 5 and 6 are 3 plus 2 cosine of theta, 1 plus 3 sine of theta. I'm just going to do one problem kind of like that because both those are going to solve very similarly. I will say number 6 kind of gives you a weird looking shape, but just take your time with it, be careful with it, and you'll be able to figure it out. There's one exactly like that in your notes, so you should be, you should have something to reference for that to be pretty okay with that. And then I'm going to do one like number 7. So the first one that I have written up here is r equals 4 plus sine of theta. So the first thing we have to do, right, is we have to determine what is the symmetry. Where is the symmetrical to? So we need to use our symmetry formulas and work through those. I know this part can be a little bit tedious, but it's gonna make it way easier. So the first thing I do is I replace negative r and negative theta. This is to test if it's symmetrical to pi over 2. That y-axis, right? We replace both of them with a negative. So I can already see what's going to happen. And hopefully you start, like I said, picking up on these patterns and seeing what's going to happen. If I make this r negative and I make this theta negative, well, this negative is going to move outside. And then when I divide by a negative r, it's going to switch this back to a positive, but then that 4 is going to become negative. So ultimately, if I simplify that all the way, I would end up with this. So try and work through it, see if you get to that. If you do, then you know you're doing it right. But this isn't the same equation, so I know that it doesn't work on that. So the other way I could try it then is to keep the r the same, but do pi minus theta. These ones are a little bit harder to see just intuitively, right? These ones we have to work out a little bit more until you kind of start seeing, which one's going to be the 1, which one's going to be the negative 1, which one's going to be the 0, all that stuff. So let's just plug this in. So I have 4 plus sine, and then inside here I've got pi minus theta. So working this one out a little bit, we end up with r equals 4 plus sine, remember, does sine cosine and then cosine sine. So sine of pi, cosine of theta, and then keep the sine and do cosine of pi, sine of theta. Alright, so with this I know that at pi we're using the coordinates -1, 0. So I'm going to replace this sine of pi with 0, and I'm going to replace the cosine of pi with -1. And then just simplify here. R equals 4 plus 0, but then I've got minus a negative, so it's going to become positive sine of theta. So 4 plus sine of theta, 4 plus sine of theta. So this does work. So I know it is symmetrical with respects to theta equals pi over 2. So let me just document that over here because we're going to need that. Okay, so then let's look at the next one. So we want to see if it's symmetrical with respects to the polar axis. So remember, with the polar axis, we're going to keep the r the same but change the negative theta. So r equals 4 plus sine of negative theta. And I already can see what's going to happen here, right? This negative is going to move outside, and you end up with negative sine of theta and no way to change that. So definitely not going to work out on the first try. Let's go ahead and try using our sum difference formula then. Negative r equals 4 plus sine of pi minus theta. You'll notice that since I left this here, we can kind of make this quick jump, right? We know that sine of pi minus theta becomes sine of theta after simplifying it. So I don't have to rewrite everything again. And at this point we can see, well, if I divide by that negative, it's not going to work, right? So this is still a no. So it still doesn't have symmetry to respects to the polar axis. Okay. Last thing to check then is, does it have symmetry with respects to the pole itself? So with this, we're going to replace just the r. And again, divide that negative through, and you can see that's not going to work, right? It's going to switch all the signs. So then we can also keep the r the same and try putting in sine of pi plus theta. So this one we're going to have to work out a little bit, but it's going to be still super similar to this, right? All that's changing is that this is going to become a plus sign right here instead of a minus sign, which ultimately means that this is going to switch to a minus sine of theta. You could just work that out if you want to, but I'm just going to use some shortcuts there to simplify this a little bit so you can see that it doesn't take as long as it might if you work every single step out. So 4 minus sine of theta, that's no good. So definitely not over the pole either. So the only symmetry that we have to worry about is theta equals pi over 2. So what that tells me is that when I go to pick points for this, I'm going to pick points that are in quadrant 4, since it's symmetrical over this axis. I just want to pick points from quadrant 4 and quadrant 1 and graph what I can, and then just reflect that over the y-axis, over the axis theta equals pi halves. That way I can see what's happening on both sides. So let's go ahead and pick some of our points to plug in. I'm going to go ahead and zoom this across now. It's not going to let me do as much as I want to. Okay, so picking our coordinates then. So again, this is where we pick our theta and plug it in and see what I get for r. So if I plug in, let's start with 0. Let's just start with the first quadrant, right? We'll do the first quadrant first, and then dogs letting themselves in. And then we'll go back and do the fourth quadrant. So first thing I plug in is 0. Sine of 0 is going to give me, well, at 0, that's the point 1, 0. So the sine of 0 is 0. And 4 plus 0 is going to give me 4. And then we could do pi over 6, and pi over 3, and pi halves. So I did 0, 30, 60, 90. Pi over 6, when I plug that in, I know that sine at pi over 6 is 1/2. And 4 plus a half is going to be 4.5. When I do pi over 3, that's going to give me radical 3 over 2. And 4 plus radical 3 over 2 is going to give me something that I don't have a calculator right in front of me, but we'll plug that in a minute. And then last, when I plug in pi over 2 for sine, I get 1. And 4 plus 1 is going to be 5. So there's my quadrant 1 coordinates. Let's go ahead, like I said, we also want to talk about what's going to happen in quadrant 4. So in quadrant 4, we already know what's going on at 0, but maybe we're going to plug in negative pi over 6. That came out super weird. Negative pi over 3 and negative pi halves. Just use it as negative, just to kind of think about what's going on. So when you switch from the first quadrant to the fourth quadrant, remember that with sine is affected by the y value. So it's just going to switch them to the opposite signs, right? So sine at pi over 6 would have been 1/2, but that means that sine at negative pi over 6 is going to be negative 1/2. So 4 plus negative 1/2 is going to give me 3.5. With this negative pi over 3, that's going to give me negative radical 3 over 2. So I have 4 minus radical 3 over 2. And with my negative pi halves, that's going to give me negative 1. And 4 plus negative 1 is going to give me 3. So there's a good representation then of what's going on here, of all my coordinates that I have. Okay, let's do this. Let's try to make a nice polar graph right here without. There's a circle. I put that up too high. Ah, forget it. Forget it. Hold, please. We'll use this one. That one's got stuff all over it. I don't want stuff all over it. I want just a nice pretty one. Copy image. Done. Paste image. Wait momentarily. Okay. It's not going to let me make it bigger. Okay, so then let's come up here then. Let's go ahead and graph these points then. So I'm going to start with this first one, right? So the first point said go over 4. Remember, this is backwards. So you do the radius first and then theta. So go over 4. Why do I do this to myself? Why? That's not the right size. There's no 4 on there. I need it to go out to at least 5. That was the ugly one I tried yesterday. It doesn't work. That one's got weird things all over it already. How about that one? We'll do that one. That one's got some extra stuff on there. That's okay. We can make that work. Okay. So trying this again. So the first one was over 4 and then with a radius of 0. So I'm going to come on here. I'm going to go over 4. So here's my origin 1, or my pole 1, 2, 3, 4, and then rotate 0. So there's my first point. My second point was go over 4.5 and then rotate pi over 6. So pi over 6 is right here. And we're in between 4 and 5. The next one is go over 4 plus radical 3 over 2. So grabbing my calculator, let's figure out what value that is. So square root of 3 divided by 2 plus 4, and I got 4.866. So it's closer to 5, but not super close. And so we know then that is at pi over 3, which is here. So it's like getting closer to 5, but it isn't quite at 5. And then my last one is over 5 up pi halves. So over 5 up pi halves is going to be right there. And then coming on this other side, we know that we're going to go over 1, 2, 3.5, and then go negative pi over 6. So negative pi over 6 is going to be right here. And then 4 minus radical 3 over 2. So 4 minus, actually let's do this, square root of 3 divided by 2, and I'm going to change that to negative and add 4, and I got 3.13. So 3.13, and then negative 1/3, or pi over 3. So negative, I forgot what I said. Negative 3.13. 1, 2, 3.13, rotate to about here. Okay, and last it says go and do a rotation at 3 units and then negative pi over 2. So 1, 2, 3. I think that coordinate's wrong. 1, 2. Yeah, I accidentally did 2. This should have been over here. Sorry, I accidentally counted 2. I got myself confused. There we go. Okay, well, I can't erase that point. There we go. Okay, so what you can see then is if I were to graph this, I have something that does like this, right? It kind of looks circular in fashion. And it comes around and touches on here. Now, we had said that this has symmetry with respects to the line theta equals pi over 2, right? This line right here. I lost where I was going at first. There we go. Okay, so what I know then is I can reflect it over this. So this one that's right here, notice that it's kind of like, you can see it's like 2 circular things away, 2 radii away. So I'm going to go over 2 radii and put the same point over here. This one over here looks like it's at pi over 6, so it would go on 5 pi over 6. So it would be right about here. Coming down here to 0, it's exactly at 4, so we're going to come over here to negative 4 and put 1 at 0. Down here, we've got this one that is at pi over 6. Kind of hard to see. You gotta be a little bit careful, especially when these pictures get crazy like this. This one came to about here. There we go. And you can see that on the other side, it's gonna do. And I can't even reach the dots. Ooh, there we go. So it should kind of be like a circular shape. In fact, I think it is a circle. 100% a circle. I think I had that up on Desmos actually. Yeah, look, there it is on Desmos, so you can see that red part. So it is just a circle. So that's what you should have ended up with. Great way to check your resources right here, y'all. Just go on Desmos, go polar coordinates. You can type in things and see if you got the graph correctly. With that said, don't use it as a crutch. Make sure you actually know what you're doing so you're not just depending on Desmos. All right, that was a lot of work for one example. So let's look at another one. This might be a long video. Okay, so the second example I had pulled out for you is going to be r squared equals 25 cosine of 2 theta, right? So our first one that we want to plug in is if we replace negative r and negative theta. Immediately I can tell you that pi over 2 is going to work. The reason I can tell you that is when I plug in negative r, well, negative r squared becomes r again, right? Just r squared. The negative cancels out. And when I plug in negative theta, well, cosine's an even function, so that negative is just going to disappear. So I instantly know that's going to work. So I know it has respects. It has the words that I'm looking for are there. It has symmetry with respects to theta equals pi over 2. Whew, that was tough. Okay, the next one we want to check then is the polar axis. So the polar axis, we would replace r with nothing and leave this negative theta. Again, think about that. If I plug r squared, I get r squared. If I plug in negative theta, well, cosine of negative theta is cosine of theta. So you're going to end up with the same thing again. So it also has symmetry with respects to the polar axis. So we also want to check one last thing then. does it have symmetry with respects to the pole? In this one, we're going to replace it with negative r and theta. Well, if you plug in negative r, you're going to get r squared again, and then theta doesn't matter. So it also has symmetry with respects to the pole. It's going to do all those things. So we got to make sure we keep track of that when we get down to solving it. Okay, plugging our stuff in. So with all that, since it has symmetry in the pi over 2, that I can reflect quadrant 1 into quadrant 2 to get quadrant 2. And since it has symmetry with respect to the polar axis, I can reflect quadrant 1 into quadrant 4. So I know what's happening in quadrant 4 as well, and then you could do the same thing to get quadrant 3. So all I have to worry about in this problem is quadrant 1. That's it, because it all reflects and makes itself. So we are just going to plug in things to get quadrant 1 to work out. And we have to be a little bit mindful of what we're plugging in, because I'm going to take whatever I plug in and multiply it by 2 theta. So think about the first thing that you usually want to plug in is 0, right? Well, if I plug 0 in here, I'm going to get 2 times 0. That's okay. That's what I want to happen. So we're good with that. Make 2 theta equal 0. So I plug in 0. I get the cosine of 0. The cosine of 0 is 1, and 1 times 25 is 25. So that is going to be a huge graph. I'm sorry. We're not going to actually graph that together. There's nothing like that in your notes. I just made that up at the top of my head. So the next one we're going to plug in is pi over 6, right? We would usually plug in pi over 6. But again, we're thinking about the fact that this is equal to 2 theta. So really what we're plugging in is whatever pi over 6 divided by 2 is, which is going to be pi over 12. So I want to plug in pi over 12. When I do, I plug it in, multiply it by 2, I get pi over 6. The cosine at pi over 6 is radical 3 over 2, and then we multiply that by the 25. So we end up with 25 radical 3 over 2. The next thing that I'm going to plug in is I want to plug in my pi over 3. So again, we're going to think critically about the fact that this is pi over 3 equals 2 theta. Divide everything by 2, so you're really plugging in pi over 6. Pi over 6 times 2 gives me pi over 3. Pi over 3 cosine is 1/2, and so we'll have 25 halves. And lastly, we are going to plug in our pi over 2. Pi over 2 equals 2 theta. Again, divide by 2, we get pi over 4. When I plug in pi over 4, I get radical 2 over 2, so I end up with... Sorry, I said that backwards. When I plug in pi over 4, I get pi over 2. The cosine of pi over 2 is 0, and 25 times 0 is going to give me 0. So with that, I've got a pretty good idea of what's going on. Actually, you can see what kind of happened here. We went pi over 12, pi over 6, pi over 4. So you can see the pattern that's going to keep happening here. Next, I want to do the one that goes with pi over 6, which is going to be the... trying to think how to phrase that correctly. So let me do it this way. I'm trying to think of the easiest way to explain this. I would probably want to just keep going then into quadrant 2. I know I said we weren't doing quadrant 2, but because that 2 theta took everything and kind of compressed it so that, look at this, like we know pi over 4 is halfway into quadrant 1, right? So just using the numbers from quadrant 1 really only gave us half of quadrant 1. So we also have to do the other half of quadrant 1, which means that we just think about quadrant 2, right? The next thing in quadrant 2 that we would hit would be 2 pi over 3. So 2 pi over 3 equals 2 theta at 2 pi over 6, which would just be pi over 3, right? So we're going to plug in pi over 3 next. So when I plug in pi over 3, I get 2 pi over 3. The cosine at 2 pi over 3, well, it's in the negative direction now, so it's going to be negative 1/2. And negative 1/2 times 25 is going to give us negative 25 halves. The next thing I could plug in would be my 5 pi over 6. Divide that by 2, so I have 5 pi over 12. That's what I'm actually plugging in. So 5 pi over 12 times 2 gives me 5 pi over 6. That's going to give me a cosine of negative radical 3 over 2. And I multiply that by 25. So I have negative 25 radical 3 over 2. And lastly, I'm going to plug in my pi. So pi is going to equal 2 theta, so it's going to be pi over 2. So I plug in pi over 2. Pi over 2 times 2 is going to give me pi. Cosine of pi is negative 1. Negative 1 times 25 is negative 25. Great. Now I got all that. Let's think about graphing it. I'm going to just do this as best I can by hand just because we don't actually have a I'm not going to be able to get a plane that has 25 super easily, and that's going to be super ugly. In fact, let's go ahead and just do this too. We'll put a circle here, and we'll say that circle is the radius of 5. I want it to go through the graph. Yeah, we're going to have to extend our graph. Okay, so right here, we'll come over here and do this. So everything is less than 25. So we'll just say that that's 25 for the sake of simplifying this. So the first one I want to graph is I want to go to a radius of 25 and then put a point at 0. The next one I want to do is go to a radius of 25 radical 3 over 2. So let's look that number up. 25 times the square root of 3 divided by 2. I get 21.65. So it's not quite away from the graph, right? So it's going to be like here. I also forgot that I should do this, right? We should put, let's do those in a different color. So there's my halfway point. There is my pi over 6 point, and there, nope, that's not the straight line feature. And there is my pi over 6 point. Okay, so with that, okay, so 25 radical 3 over 2 we said was just less than 25, and then we wanted to rotate to pi over 12, which is going to be in between 0 and this pi over 6 thing. Next we're going to do 25 halves, which is going to be exactly half of 25 up to pi over 6, so we're going to be here. And then last we're going to take a radius of 0 and graph this. So I think I actually did make a slight mistake. I could have stopped there. So I kept going up here, and you may have noticed I paused and thought about it for a second. I was like, do I have to? And then I just did, just in case. I didn't actually have to do this. So you really do only have to plug in the quadrant 1 points. Because what we said is, right, this is my graph that I have so far. Well, since it has respects to symmetry with respects to the y equals 2, I know that I'm also going to have the same exact thing happening on this side. So I just reflected it over here, and I can make that look a little bit better. Let's just do this right. So we'll put our lines on this side as well. Okay, so with my lines on that side as well, then I can easily just flip this over, right? This flips over to here. This one comes over to here, and this one comes over to here, and you can see it's got the same little shape over here. And then since it has symmetry with respects to the polar axis as well, we could then come down on the bottom and reflect it. So this one's going to reflect to here. This one's going to reflect to here. 0's there, so you're going to have this. And same thing, this one will reflect to here. This one will reflect to here. And it wraps around and does that. And so that's the shape we end up with. It kind of looks like a little infinity sign, right? And we also knew that it had respects to the pole as well. And all the pole says is that if I took this side like this and flipped it over, it would be the same. And it would be the same here. So actually, I don't think it would. Did I do that part wrong? I don't know. I may have done that part wrong. Let's see. I snipped this one. Do we think this has respects to? That's what it would look like, right? So if I went through the axis here, no, it would have symmetry. I don't know. Maybe it doesn't. I'm a little lost. I just lost myself there. But there we go. That's how you'd graph it. That's the important takeaway right there. So since I had both those symmetries, you could do it. So let me know if you have any questions. I know that was a lot. Hopefully that helps you get through those problems, though. Bye, y'all.